Now let's talk about direct addition versus conjugate addition. Now, so far we've been talking about direct addition to a carbon polar carbon bond, polar pi bond. But it's possible to have conjugate addition. So I'm just going to draw up something that has conjugation. So we've got a double bond here and another double bond there. And this one's between the two carbons. And there's a single bond in between them. So they're conjugated. We have the alpha carbon right here. We have the beta carbon right here. All right, so carbonyl carbon attack could happen there. And we've been watching that. Alpha carbon, no. Beta carbon, yes. So why is that? Well, let's draw some resonance structure here. So if we moved those electrons there, right, and then we have to shift the electrons that are in between the carbon and oxygen up as well, see another resonance structure. So now the oxygen has a negative charge. There's a double bond right here. And then over here on the beta carbon, there will be a positive charge. So what we're actually looking at is a molecule that has two locations for a positive charge. We've got a partial positive charge right here, and we've got a partial positive charge there. So we can get addition either right here in the direct position, also known as 1-2 addition, because it's 1-2, or we can have 1-4 addition, 1, 2, 3, 4, the fourth position away. Right? Now, both of these reactions are possible. So let's just go over what would happen in either case. Right? So if I start with my conjugated bond here, and I go 1-2 or direct addition, then I'll end up this. Have my alcohol up here. Of course, I'll have to do some acid workup step. And I'll have my nucleophile that has attacked that carbon. So it's right there. And that's what we've been going over so far. It's also possible to do 1-4 addition, which you may have heard it called Michael addition after the scientist who did a lot of work with this. His last name was Michael. In that case, you'll end up with this, where the nucleophile is added here. So, I'm going to go over the mechanism for the 1-4 addition, because the 1-2 addition is the same as what we've been talking about in previous videos, and you can just look at those. But remember, the nucleophile will just attack here, electrons go up, and then you'll just have to protonate the oxygen up there, and then there you are. So let's just talk about the 1-4, because that's the new one. Sticking with the same example here, I'm going to have my nucleophile, and it's going to come in and attack that place where we've got some partial positive charge right here on that beta carbon. When that happens, this double bond is going to shift up there, and those are going to shift up onto the oxygen. So we're going to get this intermediate right here. Now I've got our nucleophile attached. We've moved the double bond over to here. And now we need to protonate. So we'll just bring in some acid. And we're protonating. So we end up with this. Now, you might notice that this is not the final product, right? We have a ketone here. Well, this is an enol, right? E-N-O-L, enol. And those will undergo keto-enol tautomerism, and I don't want to draw out the entire mechanism for that. So I'm just going to say keto-enol tautomerism. And I'll call it good. There's another video on tautomerization. So that's the two possibilities. Now, what makes it go one way or the other? Well, if I have a reversible reaction, it's going to go 1,4 addition. And if I have an irreversible reaction, it will go 1,2. And I'm going to explain some of the factors behind why one of those is favored over the other. So I'll just write that down here though. So if I have really strong nucleophiles, it will tend to go the irreversible reaction, so-called kinetic conditions, right? Whereas if I have a weaker nucleophile, it's more likely to go 1,4. Now, just because it's more likely doesn't mean I will get only 1,4 or only 1,2. I'll get a mixture probably. You'll have to do the experiment to find out which one is going to be more, which one will be less, and or what the actual yields are, I should say. You should be able to figure out which one is going to be the more likely scenario based on how strong the nucleophile is. So we'll talk about that in the next video, part 2.